Okay, hi year 10. We're going to be looking at interior angles in polygons to start with. Then we'll look at exterior angles, we'll look at regular polygons, and we'll have a look at some challenge questions. To start with, angles in polygons. You will have seen this before, but it's good just to recap on it. So a polygon is a several-sided shape. You know a lot of them already. We have a few here. We have a triangle, a square, pentagon, hexagon, and a heptagon. But this works for any number of sides. So the angles in a triangle, you already know, add up to 180 degrees. So this is one triangle. Now, the interior angle for a square would be double this. And the reason for this is that it has two triangles. So we have two triangles. Therefore, the total interior angle is 360 degrees. For a pentagon, so a five-sided shape, if we start with one corner, we can see we have 1, 2, and 3. So we have three triangles. So in this case, we have 540 degrees. So 180 times by 3 in this case. Okay, next one, we have a hexagon. I'll do the same for these last two. Split it up into triangles. In this case, we have 1, 2, 3, 4 triangles. So we do 180 times by 4, which is 720 degrees. For the last one, we have 7 sides. Start on one corner. 1, 2, 3, 4, and 5. So for this last one, we have 1, 2, 3, 4, 5 triangles. So we have 180 times by 5. It's times by 5 times by 10 divided by 2. So 1,800 divided by 2 gives us 900. Okay, so if I was to draw a shape here, so we have 1, 2, 3, 4, 5 sides. This is in a regular shape. This is a pentagon because it's got 5 sides. So it's a pentagon. And you could have a look up here and you could tell me that a pentagon must have 540 degrees. So that's when I add together all of these angles. Okay, so the total interior angle for this shape equals 540 degrees. Okay, so if you're faced with a shape which has got some missing angles, have a think about what the total will be and then work out what's missing. Now there is an easy way of doing this. We can come up with a formula for this, and some of you may have seen this before. If I say I have that n is the number of sides, then hopefully you can see in this one, I'll go in a different colour quickly, let's go red. This one has 3 sides, this one has 4 sides, 5 sides, 6 sides, 7 sides. So we can see in this case, we've done 1 times 180. In this case, we've done 2 times 180, 3 times 180, 4, and 5 times 180. So we've times 180 by 2 less than the total number of sides. So I can write this algebraically, and this is really important to learn. We do n minus 2 times by 180. Essentially what this is us saying how many triangles do we have? Each triangle is worth 180 degrees, so how many triangles times by 180, and that gives us the total interior angle. And what I might do at times is call this TIA and refer to it that way. Okay, so if we think about regular polygons, so these are all regular polygons, which means they have the same length of side, all of them. Okay, So all the sides are the same length. Now, we've used that formula. I'll rewrite it up here. We have that n minus 2 times 180. And if you remember, that gives us the total interior angle for these shapes. Now, if I want to find an individual interior angle, then I need to think about how I can do that. So for a triangle, we know that the total interior angle is 180. And for a regular polygon, we have 3 angles. So what we would do is we would do 180 divided by 3, which gives us 60. And that is how big each of my angles is. Okay? I can do the same for a square. We start with 360. I divide by 4. We should know the answer to this anyway, but 360 divided by 4 gives us 90 degrees. For a pentagon, okay, remember that we started with 540 degrees. If we divide this by 5, we get 108 degrees. Okay. Finally, for a hexagon, we start with 720 degrees. Okay, and we're going to divide that by 6. So 720 divided by 6, which is, let's have a little think, 120 degrees. Okay, so each individual angle is 120. Now, let's be really clear, that is only for a regular shape. Okay, for a regular shape, all the angles are the same and all the sides are the same. We can also work out the exterior angle. So the exterior angle if I just take a snapshot of this hexagon here, so if I in green to show you what I'm going to do, so I'm going to take this bit here and I'm going to put it down here and show you what I'm talking about. So if I just take that little corner, which looks hopefully something like this. Okay, and I had my angle here, which is 120. That's my interior angle. So my exterior angle, you might be thinking, oh, it's all the way around here. That must be my exterior. No, that's not my exterior angle. So my exterior angle doesn't go all the way around the outside. It actually goes off and follows the line of the shape. So if I continue one of these lines, if I continue this line here it goes. I've continued that in a straight line. The exterior angle is actually this one. So this is the exterior angle. Okay, and in this case, remember we've got a straight line, 180 degrees in total, 180, take away 120 is 60 degrees. So the exterior angle for this shape is 60. And I could draw some of these on as well. That's a terrible drawing. I'll get over it. So here, 60, 60, 60, 60, and a final 60. Okay, well, let's take this idea. What is the total exterior angle? Well, let's add these ones up. We have 60, 60, 60, 60, 60, and 60. So how many have I got? I've got 1, 2, 3, 4, 5, 6. That makes sense. If I do 6 times 60, I get 360. Interesting. Let's have a look for a square. The exterior angle, can we see, is going to be 90. How many angles do I have? 4. 4 times 90. Anyone? Is it 360? Absolutely brilliant. Yeah, correct. It's 360 degrees. Okay, final one. Let's have a look for this pentagon. So this pentagon is going to be 72 as an exterior angle. 72 here. There's going to be 5 of them. So 5 times 72. Anyone? Brilliant. Yeah. Also 360. So they're all the same. So for every shape, the total exterior angle equals 360. Okay, now to find 1, we divide 360 by the number of sides the shape has. Okay, so for 1 exterior angle, we do 360 divided by n. Okay, we'll go into some more detail with that with some questions in a moment. So here are 3 questions for us to have a look at. The first one, I have an irregular polygon, and I want to find what A is. So I have 1, 2, 3, 4, 5 sides. So it is a pentagon. The pentagon. And what I'm going to do is work out what the total interior angle should be for a pentagon. So let's use our formula, which is n minus 2 times 180. The n is the number of sides, that's 5. So we do 5 minus 2 times 180. 5 minus 2 is 3. So we do 3 times 180, which is 540. Okay, so we've got the total interior angle. Now what we do is we take all of these away from 540 to work out what A is. So A is going to equal 540 minus 120 minus 120 minus 85 minus 115. So if you're lazy like me, do it on a calculator. We get an answer of 100 degrees. Okay, so for this type of question, find how many sides it's got, work out the total interior angle, and then work out the missing angle. Done. Okay, so for this question, we want to find the interior and the exterior angle. So for the interior angle, the first thing to do is realize this is a regular octagon. Okay, octagon. 8, octo, like octopus, 8 legs. Interesting fact for you there. So to work out one of these angles, interior and one of the exterior, we need to work out the total interior angle first and divide that by 8 for the interior. So here we go. Interior. Again, use your n minus 2 times 180. How many, what's n? That's 8. So we do 8 minus 2 times by 180. So 6 times 180. Right, well, if we know what 3 times 180 is, then we can double it. So that is 1080 degrees. Okay, so for the interior angle, we need to divide that by 8. Right, I'm going to do it on the calculator. Right, that's 135 degrees. Okay, so that one's 135. How do we work out the exterior? Well, this is a straight line, so we do 180 minus 135, which is 45 degrees. We could have also done 360 divided by 8, and that would have also given us, hopefully, 45 degrees. Yes, it does. Okay, so 2 ways of doing that second part. Great. Okay, last couple of questions. We have a total sum of 2,700 degrees. We want to work out what shape this is. Okay, well, this is a little bit difficult. It involves a little bit of algebra, but we love algebra, so we'll be fine. 2,700 equals this n minus 2 times 180. Okay, first thing to do, work backwards. Let's divide by 180. So 2,700 divided by 180 gives me 15 either here. That's 15. So n minus 2 equals 15. To solve this is easy now. Add the 2, so n is 17. So it's a 17-sided shape, which is called a 17-agon. I made that up. That's not actually what it's called. I don't know what it's called. It's a 17-sided shape. Okay, next one, interior angles of 156. Right, well, this is quite an interesting one. If I imagine a bit of this shape, here's like a corner of this shape, and I say, right, that's 156. It's a bit difficult to work out it using this formula. So why don't I think about my exterior angles? So my exterior angle must be 180 take away 156, which is 24 degrees. So with that in mind, let's think about this. 360 divided by n is how we work out the exterior angle. So if that equals 24, if I times by n, I get 24n. If I divide by 24, I get 15. So for this shape, it's a 15-sided shape, okay, which is called a half 30agon. Again, that is made up, what I've written here, that I've made that up and I've made that up. So don't, that's not what they're actually called. You can just call it a 15-sided shape. If you want to look up what it's called, you can do, but you won't be required to know it. Right, so, okay. Last thing we're doing is going to look at a problem question. And here's this question, and I'll tell you what, it's been a right problem. So we've got two pentagons and we've got a square. They're regular because it says so, and we want to find this angle x. This is a bit more of an extension question, but I thought I'll just show you how to do one of them. Just, help you out a little bit because I'm just such a nice guy. So if we think about a square, we can work out what the interior angle in a square is, and that should be quite obvious. We don't need to do all the working. We know that's 90 degrees. However, for a pentagon, let's have a think about this. So the interior angle for a pentagon, we're going to start with n minus 1 times 180. So we have 5 minus 2 times by 180. And that gives me 3 times 180, which is 540 degrees. If I do 540 degrees divided by 5, I get 108 degrees. So we know that this angle here is 108. This one here must also be 108. Now look, this goes round a point, so we know it must be 360 degrees. So let's start with 360. Let's take off 108, take off another 108, and take off a 90. And that's a weird little equal sign. Sorry about that. We'll do that again. So our x, equals, get the old calculator out again, 360 minus 108, minus 108, minus 90, gives me 52. That doesn't look right. Let's do that again. 360 minus 108, minus 108, minus 90, 54. I knew there was something up, 54 degrees. Okay, so if you're confronted with one of these problems, think about the individual shapes, think about the individual interior angles, and then work out what's missing. All right, have fun this week. If you need any help, please let me know, or have a look at the videos on MathsWatch. If MathsWatch is going down, that's not my fault. It's not my website. Just let us know that we're having problems with it. I'll send you some worksheets as well. Good luck. Look after yourselves. Enjoy your weekend. Hope the weather's nice. If you've got a dog, I'm jealous. And, get some exercise. All right, bye.